Assalamualaikum. Today, we would like to present our project entitled Design of an Upgrade Wastewater Treatment Plant for Hulu Langat District Selangor. This project is presented by Group 5. Our group's members are first Hudaidah binti Muhammad Adib, second Nazatul Sharina binti Abdul Muttalib, third Hani Yasmin binti Borhan, and myself Narfatin Najwa binti Muhammad Hafiz. In the presentation, we will discuss the background of the study, the problem statement, and the proposed design approach for upgrading the wastewater treatment plant to meet current and future demand in Hulu Langat. This presentation will cover the project introduction, problem statement, objective, method, result and discussion, followed by the conclusion and reference. In terms of our team organisation, Hudaidah is the project manager, Nazatul is the engineer, Hani is the technician, and Fatin is the operator. Each member plays an important role in the successful completion of this project. I would like to begin my presentation by introducing the background of our study, which focus on wastewater management in the Hulu Langat area Selangor. Effective wastewater management is very important because it plays a key role in protecting both public health and the environment. Wastewater that is not properly treated can contaminate rivers, groundwater, and surrounding ecosystem, which may lead to serious environmental degradation and health risks for nearby communities. In recent years, rapid urbanization has occurred in Selangor, particularly in the Hulu Langat district. This rapid development has resulted in a significant increase in population, housing areas, and industry activities. As a consequence, the volume of wastewater generated has increased, along with higher pollutant loads into the wastewater treatment system. Hulu Langat has experienced significant development pressure, especially from residential and commercial growth. This development placed a heavy burden on the existing wastewater treatment plants. Many of these treatment facilities were originally designed to serve smaller population and lower wastewater loads. However, due to current growth, several plants are now operating near or even beyond. When wastewater treatment plants operate beyond capacity, their efficiency may decrease. This can result in incomplete treatment, higher pollutant discharge, and potential non-compliance with environmental regulation. Over time, this situation may negatively affect river water quality and downstream ecosystem. Therefore, upgrading and redesigning the existing wastewater treatment system is necessary. Improvements are required to ensure that this system can cope with current and future wastewater demands. By enhancing treatment capacity and performance, sustainable operation can be achieved while also ensuring compliance with environmental standards. This study highlights the urgent need for effective wastewater management planning in Hulu Langat. Understanding the current challenge faced by wastewater treatment plants, it is essential to support sustainable development, protect water resources, and safeguard public health for future generations. Next, I will explain the problem statement of this study. One of the main issues faced in the Hulu Langat area is rapid land use change. Urban development such as housing, commercial areas, and road construction has significantly altered the natural landscape. As a result, surface runoff has increased, carrying higher amount of sediment and organic matter into the wastewater system. These changes have placed additional stress on the existing wastewater treatment plants. Most of the current WWTPS in Hulu Langat were originally designed to handle lower flow rates and smaller population equivalents. However, due to rapid development, many of these plants are now operating under overload condition, which reduce their overall performance. Another major problem is the high sediment and organic content in the incoming wastewater. Excessive sediment interferes with primary treatment process such as screening and drift removal. When these systems are overwhelmed, sediment can pass through to downstream treatment units, causing operational inefficiencies. Operational issues have also been observed within the treatment plants. These include increased large blanket rise, reduced treatment efficiency and higher maintenance requirements. Such problems not only increase operational costs but also raise the risk of system failure and non-compliance with discharge standards. Furthermore, the current wastewater treatment plant design is no longer adequate to meet present and future demands. The existing system was designed for a population equivalent at least 5,000 to 15,000 PE, which is insufficient considering the current development trend in Hulu Langat. This clearly indicates the need for an upgrade and improved wastewater treatment system. Rapid land use change, overload treatment capacity, high sediment and organic loads, and operational inefficiency have created significant challenge for wastewater management in Hulu Langat. Addressing this problem is essential to ensure efficient treatment performance, environmental protection, and long-term sustainability of the wastewater treatment system.
Next, I will like to explain the objective of this project. The main objective is to carry out design calculation using Microsoft Excel and to prepare engineering drawing using AutoCAD. Furthermore, this project aims to identify the factors contributing to post-monsoon sedimentation and sludge handling problem at the treatment plant. For the methodology, I will start with the site location and data collection. The selected location for this project is Hulu Langat, which is a semi-urban area. In the data collection stage, we collected important design data such as population equivalence to use to estimate the wastewater flow and loading for the treatment plant design. For problem identification, we found that during monsoon season, more sediment entered the treatment plant. It causes problem in the sedimentation process and also affect the sludge handling system. For to improve, we propose for the sedimentation unit and the sludge treatment system. For example, the image show the sedimentation tank and the activated sludge treatment. For the design tools, Microsoft Excel was used to perform all design calculations, such as flow estimation and unit sizing. AutoCAD was used to prepare the layout and unit drawing for the wastewater treatment plants. These tools help ensure that the design is accurate and clearly presented. Finally, the design was evaluated to ensure compliance with the Malaysian sewage industry guideline, and all findings will comply into the final report. That's all for me. I would like to pass to the next presenter.
Warahmatullahi wabarakatuh. My name is Reda and I will present about result and discussion. For this section, I will present the result and discussion of our wastewater treatment plant design. The plant was designed based on MSIG Volume 4 with a total design capacity of 10,618 population equivalent. We adapted an activated sludge process with extended aeration to ensure stable treatment, performance and compliance with design guidelines. The influent wastewater characteristic used in the design represent typical domestic wastewater. The influent BOD is 250 milligrams per liter, suspended solids is 300 milligrams per liter, and oil and grease is 50 milligrams per liter. These values indicate moderate organic loading, which is suitable for biological treatment using the activated sludge process. The wastewater flow was estimated using a per capita flow rate of 225 liters per person per day. This resulted in an average daily flow of 2,389 cubic meters per day. A peaking factor of 3.62 was applied to account for daily variation, giving a maximum flow of 0.100 cubic meters per second. All treatment units were designed on this peak flow to ensure safe operation. A mechanical cost screening unit was provided at this first treatment stage. The screening channel width was revised to 1.5 meters with a total of 43 bars, each having 25 millimeters clear spacing. A 25% blockage allowance was applied to account for partial clogging. This design reduced flow velocity and head loss while effectively removing large debris and protecting downstream units. After screening, a horizontal flow grid chamber was designed to remove sand and grit. The chamber operates at a horizontal velocity of 0.2 meters per second with a detention time of 3 minutes. This allows inorganic particles to settle while preventing organic solids from depositing. Effective grit removal helps reduce abrasion and maintenance issues in downstream equipment. A grease chamber was included to remove oil and grease before biological treatment. The chamber was designed with a detention time of 20 minutes to allow grease to float to the surface. Removing oil and grease at this stage prevents foaming, diffuser clogging, and oxygen transfer problems in the aeration tank. This improves overall plant reliability and performance. The biological treatment system uses an extended aeration activated sludge process. An F/M ratio of approximately 0.05 per day was adapted, which is typical for extended aeration systems. The mixed liquor suspended solids concentration was assumed to be about 3,000 milligrams per liter. Fine bubble diffusers were used to provide efficient oxygen transfer and uniform mixings. The low F/M ratio indicates that there are sufficient microorganisms to treat the incoming organic load. This results in high BOD removal efficiency and lower excess sludge production. Extended aeration also provides stable performance under variable flow and loading condition, making it suitable for this design capacity. Overall, all treatment units were designed in accordance with MSIG guidelines and include appropriate safety factors. The preliminary treatment units protect the biological process, while the extended aeration system ensure effective treatment. The integrated design allows the plant to operate reliably under peak flow conditions. Also present about entrepreneurial opportunities. So for this slide highlights the entrepreneurial opportunities that can be developed from our wastewater treatment plant design. Although the main purpose of the plant is wastewater treatment, it also creates opportunities for sustainable business and green technology. These opportunities can generate economic value while supporting environmental protection and sustainable development. One major entrepreneurial opportunity is the reuse of treatment wastewater. The treatment effluent can be used for irrigation, construction activities, and cleaning purposes. This reduces dependence on potable water and provides a continuous, low-cost water source. Businesses can be developed around supplying and managing reused water treated water and managing reused treated water. The opportunity comes from sludge treatment. Waste activated sludge from the treatment process can be processed into compost or organic fertilizer. This supports the circular economy by converting waste into useful products. It also reduces disposal costs and creates an additional source of revenue. Also, business opportunities in operating and maintaining the wastewater treatment plant. This includes service such as routine inspection, equipment maintenance, and system optimization. In addition, green technologies like energy efficient aerators, variable frequency drives, and solar power can be introduced to reduce operating costs and environmental impact. Digital solution and training services provide further entrepreneurial opportunities. Smart monitoring systems and automation can improve plant efficiency and compliance. The treatment plant can also be used as a training and educational platform for students and operators. Overall, these activities create jobs, support local business, and promote long-term sustainable growth.
Next, for the conclusion, the proposed wastewater treatment plant is designed to serve a population equivalent of 10,618 PE in accordance with the Malaysian Sewerage Industry Guideline, Volume 4. The design is based on typical household wastewater characteristics such as a biochemical oxygen demand, BOD, suspended solid, and oil and grease, ensuring that the selected treatment process are suitable for domestic sewage. The hydraulic design consider average, peak and minimum flow conditions so that the treatment system can operate smoothly during daily flow variation and extreme flow situation. For the preliminary treatment unit, which includes screening, rich chamber and grease chamber, are properly sized to remove coarse solid, inorganic grit, and oil and grease, thereby protecting downstream treatment process from damage, clogging and operation problem. The secondary treatment process uses the extend erosion activate sludge system, which is provide effective organic removal, a stable biological environment, and reduce excess sludge production. Overall, the integrated hydraulic and process design ensure that the proposed wastewater treatment plant can operate reliable under various flow conditions and is suitable for long-term wastewater management. That's all from us. Thank you.